Hi, in this video we are going to talk about unordered set in C++ STL. We already talked about set in C++ STL. So most of the functions that you see here, they are going to be same as set. Their behavior is going to be same as. Although their internal implementation is going to be different because set is based on red black tree, but unordered set is based on hashing. We'll talk about internal implementation and time complexity details later. Let us now understand individual functions. How do we create an unordered set? We use unordered set, data type for which we want to create the unordered set, and the variable. Now this insert function is used to insert items into the unordered set. So its syntax is similar to set insert. However, internally elements are stored in a different way in unordered set. Please remember, set is a self-balancing binary search tree like red black tree, but unordered set is hashing. So there is no order among the elements. In hash table, elements might be stored in any particular order. So if you traverse this unordered set and if you try to guess the output, you may get different output on different compilers. So if you run this program, you may get 10, 5, 15, 20, 15, 5, 20, 10. So no particular output is there. No particular output can be predicted. So it can be, it's basically I can say all elements in any order. All elements I mean 10, 5, 15 and 20. So this may be this, or 5, 10, 20, 15, 20, or maybe any other permutation of these numbers. So unordered set does not maintain any order of the elements. Let us now talk about some functions on unordered set. So the begin function, end function, we have been talking about them. What begin function does? It returns iterator to the first element. What end function does? It returns an iterator which is beyond the last element, right? It is used to check whether we have reached end or not. What will be the output of this program? Again, we are traversing this unordered set in using an iterator. We'll get items in any particular order because we do not know how unordered set is going to store items internally. It depends upon the hashing function that it is being used. So the output is a permutation of, like earlier output, it's a permutation or any order of 10, 5, 15, 20. So these four will be printed in any order. Now let's talk about the size function. Size function tells you the size, so the output is going to be 4 because there are 4 elements. Clear function, it clears the unordered set. Clear function can be useful whether you are using set, unordered set or vector if you are using it for multiple test cases. So you might want to clear the container before starting the new test case, right? So you generally clear it at the end of the loop before you start the next particular test case. So after clearing, if I try to print the size, I'll get the size 0. So the output is going to be this, then 4, then 0. That's the output of this program. Let us now talk about find function on unordered set. The find function finds if an element is present or not. If the element is present, then it returns iterator to that element. Iterator is address of that element. If the element is not present, then it returns s.end. So here we are using it to check whether 15 is present in the unordered set or not. So 15 is present, we have inserted it, so the output is going to be found. We have checked whether the find returns an iterator which is equal to s.end or not, because it's going to return an iterator equal to s.end if the element is not present. So if it does not return s.end, we say found. If I try to print star iterator s.find 15, whatever iterator it returns, what it will print? It will print 15, right? This will print 15 because it returns an iterator. Let us now talk about count function. Count function can be used as a substitute of the find function. The find function returns an iterator if the element is present. On the other hand, count function returns either 1 or 0. It returns 1 if the element is present. It returns 0 if the element is not present. Why 1 and 0? Because like set, there cannot be duplicate keys in unordered set. Now if I try to insert a duplicate, say after this I insert s dot insert 5, what will happen? It will ignore this insert operation. It will still have these 4 elements. And if you try to get the size, after this insert also you will get the size as 4 only. If you try to insert 5 again or any other duplicate value, you will still get size 4 only. The size will increase only when you insert a value which is not already there. So count is going to return either 1 or 0 because an element cannot be present more than once in the unordered set. Let us now talk about erase function on unordered set. Like set, erase function is used to remove an item or remove a range of items. Here in this example, I'm using the same unordered set with the elements 10, 5, 15, 20. So when I print the size, I'll get the size as 4. Output of this program is going to be 4. Now I erase 15 from it. So 15 will go away. And after that, if I print the size, I'll get the size as 3. So this is one way of erasing where we pass the element, right? Where we pass the element we want to delete. Another way of erasing is we pass the iterator. We find the iterator using s.find and we pass the iterator. And this will also remove the element. So the size after removing the 10, so 10 is removed with these two lines with find and then passing iterator. After removing 10, size will be 2. So the output of this program is going to be 4, 3, 2. We can also use erase function to remove a set of elements. For example, like the set erase, we can pass the iterator, beginning iterator from which we want to remove. We can pass the end iterator, the point till which we want to remove. So begin iterator is included, end is not included. Everything before the end is deleted. So I passed begin and end. Please remember, end is a special iterator that points to an element beyond the last element, right? So it will remove everything. And we don't know the internal ordering. They might be stored in any order, but this will remove from first to last every element. And after that, if you try to print the size, you will get 0 because everything is removed from the unordered set. So the output of this program will be 0. Let us now talk about internal working and time complexities of an unordered set. An unordered set uses hashing internally. So with hashing, you have the time complexities of search, insert and delete as big O of 1 on average. If you remember the hashing data structure, it assumes that your hash function uniformly distributes the items, and if the items are uniformly distributed, then every chain is going to have some constant number of items. If you have a hash table of size n, and if you are having n items, and if every item is being distributed uniformly in every slot, then every slot is going to have on average 1 item. However, there can be slight variations. A slot might be having 3 items, 4 items, but they are all constant. So hashing on average takes constant time under the assumption that your hash function uniformly distributes the data across the different slots of the hash table. So with this, you get the time complexity of search, insert and delete as big O of 1 on average. So these operations, insert, erase for a given value, erase for a given iterator, find and count, they are all big O of 1, right? And the functions begin, end and their constant versions like C begin, C end, they are all big O of 1 like any other container because we have variables stored inside the container to get the begin and end elements quickly. The functions like size and empty, they are also big O of 1 because size is internally stored with the container and empty is just checking whether size is 0 or not. Let us now talk about applications of unordered set. Unordered set is mainly implemented using hashing. Hashing has this great thing that search, insert and delete can be done in big O of 1 time on average. So whenever you need to do these operations on a set of keys, you want to do search, insert or delete, or you want to do a subset of these three operations, you can use unordered set because there is no other container that can provide these operations, these three operations in constant time on a set of keys. Please remember, there are more implementations of hashing, but the unordered set works only on keys. There are implementations like unordered map, which work on key value pairs. So whenever you have only keys, you want to store them, you want to have the operation search, insert, delete or a subset of these operations, you use unordered set. So in this video, we talked about unordered hash, we talked about its internal working and time complexities of different operations.